Okay. So the two applications called Process Workflow and Ontoview, just to give you a little bit of context as to where this is coming from, as Sir mentioned, we are working in collaboration, CUBRC is working in collaboration with the University of Buffalo, and in particular with Barry, on a program funded by the Digital Manufacturing and Design Innovation Institute, DMDII. We're calling the project the Coordinated Holistic Alignment of Manufacturing Processes. We went a pretty long way to get that acronym of CHAMP. And the objective of the project is to implement a data curation process to serve as a low-cost solution to the issues associated with data heterogeneity that are present within and across various platforms. So in short, what we want to do is create a system, a platform that has these components. So at the center of these components are the ontologies that are being developed. And on the one side, the data entry and alignment, what we want to be able to do is, well, actually two things. We want to be able to have manufacturers enter their legacy data so that it conforms to the ontologies. And we also want them to be able to enter new data in accordance with the ontologies so that that will get stored into a central knowledge store. And then on the other side, on the right-hand side of things, our goal is to create, and I'll talk a little bit more about it later, but an integrated data management system. So this would be the analytics queries that sit on top of that knowledge store that actually unlock the value of that data. So I'm sure Barry has mentioned this to you, but here's a depiction of the ontologies that are being used in this project. So at the top, of course, there's basic formal ontology, and then a set of mid-level ontologies called the Common Core that were developed here at CUBRC, which are an extension and elaboration of basic formal ontology into a set of component ontologies ranging from qualities and agents and artifacts and events to units of measure and information and so on. So the idea here is that, yes, while it's true that there are a lot of ontologies out there that are that have to do with units of measure or with geospatial or with information, what was lacking was a set of these that were all unified under basic formal ontology so that we get the repeatability of the structures, of the expressive structures that basic formal ontology gives us. So the Common Core provide us a vocabulary for generic but commonly used terms inside of all domains. And the idea is to sort of have something similar to programming libraries that perform basic functions so that you can take that Common Core and extend it to your particular case. So in this project, we're extending them into the product lifecycle ontologies. And the ontologies there in the sort of orangish red square are those that are being created primarily through the University of Buffalo's efforts. So this was the project manager on that side of the table is Neil Ott, and he is leading a group of graduate students, taking also, a lead from Barry on the product lifecycle ontology, the commercial entities ontology, and services ontology. That's kind of the mid-level or the upper level of the product lifecycle, and then they're extending those down to include things like design, manufacturing processes, testing processes. The ones in white are planned but not yet created, and then even more specialized, they've created a machine. So this is really the heart of CHAMP. It forms that common vocabulary to which all data is going to be aligned, and on top of which, once we have that knowledge store that's all aligned, we should then be able to perform the analytics and discovery that we want to do. So in terms of the data entry and alignment aspects of CHAMP, we want to create interfaces that allow users to add content, whether that's designs, production plans, manufacturing data, if they want to enter new data about their parts, about the functions of components or subassemblies, of failure modes of subassemblies, and how those are then chained together to create a fault in the overall product. So that these interfaces then allowing them to add that content to the knowledge store that's conformant with best practices, and what that means is that it's aligned to the ontology. So that's with you have sort of the greenfield entry. So here a new manufacturer cracks open CHAMP and enters new data about their designs, production plans, manufacturing data using CHAMP. So that's one interface that we want to create. But we also wanted to create a way for people to pull in their legacy data, because that legacy data is very valuable, but typically, at least in the cases that we're familiar with, these tend to be scattered in many different types of places: relational databases, Excel spreadsheets, Word documents, and what have you. So for example, something like this is what we found. So here's a test result, a set of test results about a particular product that's stored in an Excel spreadsheet. So just a little bit of history. Our first attempt to map those types of things to the ontologies, we used an R2RML mapping tool. So if you're not familiar, R2RML is a tool that allows you, actually it's a language, a vocabulary that allows you to map sources to ontologies. And Karma is an interface, an editor, an R2RML editor that allows you to take those, in this case, Excel spreadsheet, and map it to the terms of the ontology. And I realize that graph there is very difficult, impossible, in fact, to read, but really what you're looking at here are these are the columns from the spreadsheet. These are some created columns. And then these links and these arcs are ultimately mapping those up to terms in the ontology. So it is very effective. It allows you to do this, and once you have these mappings, you can generate RDF, that is, translate the Excel data into data that's aligned to the ontology. But there was a problem, and the problem was that really what we want in the ontological representation is a very large connected graph. So if we have, in this case, we have a production run. That production run produces a lot. That lot is composed of a number of instances of an artifact that have a serial number. The production to produce that is composed of a number of subtasks. Those subtasks could be test processes. Those processes could be guided by documents. They're going to use tools, machines, portions of material. And what happens with the Karma mapping tool when you're trying to map those individual Excel spreadsheets is that you can only map them to segments of this large connected graph. So sure, I could say, okay, for this particular test, on this particular set of widgets, then these were the values that they had. But we wanted to connect those serial numbers, that test, to the actual production run that they came from. But it was very difficult to do that. We needed something that would allow us to do precisely what we wanted. In this case, take those test values and link them to the production run, but that was the key. How can we generate the entire connected graph and still allow people a fairly easy way of linking that legacy data? So that's one problem that we want to tackle here. And the other problem is, all right, so here's a set of production plans, a very small snippet of an overall production plan for creating in this case, just a very small part of the battery contact subassembly. So really all we're doing in this particular task is crimping a wire to a rivet and then testing the resistance of that using a milliohm meter, and we're also going to perform some pull tests on the first and last 10 pieces in a day. So here we want to take something like this and allow that to be entered into the legacy, from legacy data into the ontological format as well. So here we jump a little bit into a demo. So our solution to that is something that we're calling process workflow. And for this, we have to give credit to Remo here. He's our developer. And so a couple of things to point out. This is, we're not presenting this as a finished tool by any means. We've been on the project for 6 months. We've been working on this probably for about 4. And it is in a state of development. So just as context. So, all right, so how do we do this? Well, we start off at a home page. And I've already done one that mimics that small snippet of the process that I mentioned, namely the crimping of the wire to the rivet. So here, I jump to this. So I name the process. I give it a description. It's an assembly process with 2 testing subtasks, one for resistance and the other pull strength. I say what its type is. I select the product that's to be generated. So in this case, that is battery. Sorry, let's just call it an electronic component for now. And by the way, these drop-down menus are coming from the ontology. So one of the things that we really want to leverage here is the flexibility that the ontology gives us. So one of those types of flexibilities is shown here. In this window, what you're looking at is the query that populates those drop-downs. So in our case, the process type, we specify a parent class, and then we specify the namespace, and we specify whether or not we want recursive search or not. That's deep search. So what this is telling the machine, what it's telling the query when it populates that dropdown, is to use active production as the parent class, look for everything that has the namespace of the PLC ontology, and then do a recursive search, so return all subtypes. Now, it just so happens that in that particular set of parameters, the only thing that's produced, the only thing that's returned is active production, and that's what we wanted. That doesn't necessarily mean that that's what everybody will want, and so you can adjust this as needed. Look at the ontology, create your own ontology that extends from the ontologies that are already there, point this to a parent class, give it the namespace that you want. You can leave it blank, and that returns all namespaces, and then decide whether or not you want to return all subclasses or just the direct subclasses. And that goes for all of the drop-down, so that's specified here, or shown here. So this page is available right now. It's not editable. I can't go in there and change it. But the idea will be that it will be visible to a user with certain privileges. Some privileges would allow people to see it but not edit it. Others would not be able to see it at all, and some would be able to both see and edit this. All right, so returning to the example. So I go in, I create, that's the overall process, and now I'm going to assemble the battery contact and crimp the wire to the rivet. I enter my notes. And this could be more expensive. I could put in all of this in this note. And that would be visible to, so this is creating the process plan, by the way, right? So this isn't, and that's for then showing as the process actually occurs from workstation to workstation. These are going to be displayed to that view as well. All right, so going forward then, what are the inputs here? So there's a bug here. So when you come back in after having created, the type of input goes back to the default. So this fixture was selected as being a material. The strand of wires and material. We need a pneumatic crimping tool. There's a stop. And again, all of this is coming right from here, the pneumatic crimping tool. The various types of stops, the fixtures, force gauges, and so on, selected as being the types of inputs that you need to perform this task. So there's on the strand of wire, I figure if we're going to create 100 of these things, and they all need to be cut to about 1 1/4 inches, kept it pretty tight here. I gave them 120 inches of wire to work with. Of course, that could be modified. The rest are just left to 1 each because I'm using the same crimping tool over and over again. Oops. Actually, I should have had more rivets there, but you get the idea. All right, the output are going to be 80, so I'm imagining that there's going to be 80 of these battery contact assemblies created, because out of the 100 that are actually being created, 20 of them are going to go through the testing processes. So the output in this particular case are only 80. I select an agent. Again, this all comes from the ontology, and the query that we've used. So we get to pick a few roles. And then we can create subtasks. So in this particular case, the crimping the crimping action has 2 testing acts as sub-processes. So this is the resistance test. I'm using the milliohm meter. I'm using 20 of the battery contact assemblies that I've created in the previous process. And then my test outputs are a resistance value. I give it a name, wire to rivet. I could select ohm, but it's not in our list. But many others are. It's just one that turned out to be, of course, the one that wasn't there. And then we're going to say there are going to be 20 such results. And the same thing then is true for the pulse strength test. The inputs, if you remember, are a fixture. There's a force gauge, and of course the battery contact assemblies again. There's a note here to remind the tester what the minimum pull strength is. So not only can I create inputs of tools and materials, but I can also add documents. So if there was a document that said the acceptance test procedure, and our vision is that not only will we be able to select the type of document, but once we select that, we can also pull from a number of instances that are on a file server somewhere, so that when the person's actually performing the task, they can click on a hyperlink and take them to that document directly. All right. And this is, you can get into as much detail as is possible here. The overall process could be many steps, one preceding the next. It can have subtasks. So the subtask can have subtasks based upon their inputs, outputs, test outputs, who's performing them, and so on. Okay, so once this is set up, now if you recall, one of the problems we were trying to solve was how are we going to allow people to enter data from legacy that would then be joined to the overall process workflows or production runs. So in order to do that, we go to the data input tab. In this case, let's say we're just going to do one. Select end date, customer, So you see now this is pulling in the process plan that we've just created here. So there's the notes, the inputs, how many outputs are there, so the battery contact assemblies, you can enter the serial numbers, and this is either going to be by comma separated list or through a range. You can say how many were rejected, how many were scrapped. Going into the test resistance step, the same idea. I select off my inputs, and while not ideal, this is where you would currently enter your value. So 0.052, 0.056, and so on. So rather than entering them into the spreadsheet, as is done currently, we're getting the people to enable them to enter it into a digital format. So then we'd save this off. And those values then in the back end are then linked to the overall process. So legacy data is then entered almost the same way as new data is entered. So you would take any kind of test results that you would have for various production runs, customer for whom that production run was created, and you'd enter that data as if you were just doing it for the first time, making that production run for the first time. Since you're doing it that way, though, all of the data is joined together into that connected graph that we're looking for. So that's where process workflow currently stands.
Bon, I'm sorry, this is Sherm. Can I ask a question?
Oh, please do.
So earlier you showed like extraction of the data from the original database. Which part of the data you were showing that were extracted from the database?
I may have misspoke, Sam. So is this what you were mentioning, like the database sample?
I'm not sure. You mentioned using the R2RML to extract the original data into the RDF.
Right. Yeah. So that was one attempt, right? Yeah. But we found that lacking because we couldn't easily join it to other data. There was a problem of, I guess you could almost call it entity resolution. So sure, you've got this test result, or this set of test results. But there's another set of test results for that same work order, 24515. And it's for another step, maybe a step that happened 5 steps from this one in the overall production plan. So if you're trying to create a graph like this one, and all of these are instances, imagine them as data points. So this production run square is really a data point, and it's production run 25414. You've got some test results over here, and you want to make sure that you can say, oh, this test result, part of this production subtask, is part of this active production that went into this production run. And by the way, this was performed by quality assurance person number 16. The R2RML editor, really, it wasn't easy to do it in that way. So what we were looking to do is, how do we create this graph in an easy way and still allow people to enter just the test values that they have available to them in the legacy data sheet.
Mm-hmm.
Right? So I'm sorry, maybe that wasn't even your question, but
Okay, yeah, that's answered my question. Now, if I may ask, I don't know, if would you be able to step back a little bit and kind of describe the like the wood business case for this particular project? What is the business problem or business requirements you were trying to tackle or make better?
Right. So we imagine, so there are many applications that do this, namely allow you to enter your manufacturing data, put and ultimately what we want to do is connect not only manufacturing data, but we want to link the manufacturing data.
Mm-hmm.
What products were produced, when were they produced, what materials were used, to the design data. And we want to link the design data and the manufacturing data to the maintenance data. And so we want to connect all of the data throughout the life cycle so that we can, I guess in a certain sense, unlock the promise of big data, right?
Mm-hmm.
To discover insights from the data that were currently unavailable to us. And as I say, there are many products out there, maybe not many, but there are certainly products out there, but they all have a very large price tag associated with them. And so what we're looking to do is to actually create an open source alternative to those and enable that same type of data view for manufacturers at a far lower cost. In fact, at no cost except for the level of effort it takes to generate the data. So this is really what we're trying to do. If you're a manufacturer, we want you to be able to create a knowledge store based upon all of the data that you have and perform analytics on top of that to understand your production processes better, to look for improvement opportunities and so forth.
Got it. Thank you.
Yeah, it's a grand effort, and really, we don't hope to conquer that effort. We hope to start it. And that's really what we're up to here. The data entry part, the process workflow that we've just seen here, is the data entry and alignment part, or at least part of that. And as you see, it needs further development, of course, but we're progressing along that line so that people can enter in, okay, here's my manufacturing plan. Here are the steps that are involved. Here are the tools that are needed.
Yeah, and if I may follow up on that question from Serum, what capability is gained from your approach that promises for that cost to be lowered, if that makes sense?
Oh, well,
as opposed to traditional big, database systems, I guess that's what you were comparing in the way of cost?
Right. Well, right. So on the simple answer is that this will all be provided as open source. So a manufacturer who's interested, and we're hoping that we'll continue this process, and maybe if we're lucky, people will take an interest in it, and it'll become an open source project and develop it to a more mature level. So that's one way. Now, if it comes to a point where I'm a small manufacturer in, let's say, Buffalo, New York, I'm just starting off, and I'm looking around, and I can see that I can do, an Oracle system, but it's going to cost me $250,000 plus annual maintenance, or I can try this open source version. Well, then that's my cost savings. Now, in addition to that, I am a big advocate of the ontological integration of data as opposed to the more traditional data structures like a relational model, or for that matter, even the so-called NoSQL models, because it's extendable. Since the domain is so large and the scope of what we're trying to do here extends so broadly, that the graph model of connecting data is just much easier to do. You can, if you do it right, doing it right, in my estimate, means that you do it based on a single upper ontology. So sort of this pyramid structure of ontology development, so that when I develop a machine and tool ontology, it has a similar structure to something else, like a recycle ontology or an end-of-life ontology. So because ontologies are extendable, I think it has a much better chance of succeeding rather than trying to do this or structure the data in some other format.
Okay, thank you.
Sure. Now, having said that, it's not to say that this is without problems. So, as I say here, trying to do this an ontologically complete representation that facilitates the delivery of the promise of big data, which is, in my opinion, or at least the way I understand it, what we're supposed to be able to do is take all of this great data that we're capturing through sensors and through reports and other ways, bring it all together and come up with great new insights into our processes and to the things that we take for interest. But trying to do that about all performances of all phases of all processes can really go far beyond the capabilities of the current technology. And for a given manufacturer, particularly one who is in our market niche of someone who's sort of a low-cost manufacturer, we're not really talking about people who are developing medical devices. We're talking about the lower-cost manufacturer. They may not need to know every bit of information for all of their processes. So, for example, if you think about it, all right, so just take how you could expand. So take one force gauge. So this thing in the center here is supposed to be an instance of a force gauge. And that thing is prescribed by a certain model type. In this case, it's the FB50. It was produced by Torvald. It was produced at a production facility on a given date. And now that it's in my possession, I use it to perform certain tasks. And there's only 7 here, but there could be hundreds and hundreds of tasks. Those, of course, were all performed on a given date. They all had a certain output, the reading that the force gauge gave. The force gauge has various functions. Those functions are realized in the task. So not to drone on here, but it's infinitely extendable. So the model here is a result of the Torvald design process. So that then opens up a whole set of events that Torvald. So if this is my data, and I want to share some of my use and the maintenance processes that I had to perform on their gauge in order to help them produce better force gauges, well, that links back to their model of the design process that went into creating that model. The maintenance process links out here to a whole set of scheduled maintenance and who performed them. So that links to another set of information.
May I make a comment here or ask a question? This is Dimitris.
I'm sorry, what's the question? Yeah.
May I make a comment or ask a question? So force gauge, we can say that this is a product here.
Yes.
Yeah. So I remember last week we discussed about this exercise, the experiment, and one of the colleagues said that it will be very interesting to have a good definition of a product, what a product is. And what I see in this picture, there are various elements that have to be included in this definition. So.
Right. I don't disagree with you. This is a very, and I'm really only trying to represent here the complexity of what might be considered.
I understand very well.
And so your point is well taken that even here, there's much that's missing. And I would certainly agree with you.
I understand very well. Yeah, good. Let's say good input for reflection and discussion about this because you have functions, you have product, and everything which works or needs to be done around the product in this context. Yeah, thank you.
Sure. So what we're trying to do in another part of a research that's being accomplished during this project is allow for a much more simpler representation or persistence of the data, maybe even like key value representation of the data, and look for ways to, I like to call it hydrating that into the fuller representation on demand. So as long as I capture all of the data, all of the dates and the maintenance processes, I don't really need to store it in the graph if I can then grow it into the graph. Now, why bother doing that? Well, the thought is that it's in the graph format that is much more easily linked to other graphs. So if I hydrate my product information and Torval hydrates their design information, then those hydrated versions will be much more easily linked and shared, connected, rather than the key value representation. So I mention this just because it is a challenge for graph representations of data. They simply do outstrip the capabilities. Particularly in large manufacturing, you could imagine that this would easily run to a problem of scale. Okay, so finally then, there is the other component that I didn't mention, right? So there are three components. There's the ontologies, there's the data entry, which is process workflow, and then there's this integrated data management system. So here we have yet to really conquer this. If you read this, you can see it's, again, pretty ambitious, right? We're going to have the integrated data management system is going to have every product that's associated with the bill of materials. There will be failure modes that can be added to any product function, test procedures, test requests. This is where we want to take that to. But we're not going to get there in this project. But what we would like to do is build the basis for it. And our current step in that direction is something called Ontoview. And in Ontoview, I'm not sure of your familiarity with the whole RDF, OWL, semantic web toolkit, but you have RDF data, you're going to query that using Sparkle, and it's the age-old problem of, well, I'm a manufacturing engineer, and yeah, I can write a Sparkle query if you force me to, but I'd rather not. Or I'm a test engineer, and really all I want to see is the test results. I really don't want to have to learn a whole new language. So what we're trying to do with Ontoview is allow people to simply browse data using hyperlinks. So this is Ontoview, and really it's kind of like browsing the web, except that instead of browsing the web, you're browsing your data. So at the start of it all, you select a class. And by selecting that class, then it pops up a set of instances. So if you're looking at this and you're saying, boy, that's rough, again, this is very initial phase here, so we will have more human readable text here in order for you to be able to pick which instance you want. But when you do, and you say, okay, fine, I'll click on this guy, then that takes you to a battery contact assembly and all of the one-hop attributes of that entity. Now this button here that says start tracking the query, what this now does by clicking on this, now when I follow these hyperlinks, the Ontoview tracks my progress. So now I say, okay, so I've got this contact assembly, and that is the input of this process, and that process has is part of this process, which is an active crimping. And for rounding it off, I select the name of that process. So what's happening here is that the application is tracking my progress. And so if I click Start Building Query again, what that does is it generates a Sparkle query behind the scenes. Now again, this is still, fairly technical. We'll progress with making it more user-friendly. But the idea here now is I can now operate on this skeleton query in a couple of different ways. I can click on this, for example, and say, I think what I'd like to do is treat that not as an instance, but rather as a variable. Use this instead. So now what that's done is rather than say just return basically the same instances that I just looked at by browsing over them, give me all of the acts of resistance testing that were done. So it changes my query. I can generalize. Notice how that instance, that URN, was replaced now with a parameter. So now this thing is not going to be the input of a particular process, but of any process that's of type active destructive testing. So the idea here is that this will be the tool that will allow people to browse their data and form canned queries, or even ad hoc queries that will allow them to then generate reports or output that they can then run analytics upon. So this is their query interface for somebody who doesn't really want to learn Sparkle into their data. So those are it. That's kind of what we've got going so far. We've got process workflow for data entry and alignment. We've got the ontologies that are being developed by the University of Buffalo and in part by us. And then we've got Ontoview as well as some analytics and such waiting in the wings for querying the data and then performing analytics upon them.
Hi, I had a question. Now we are talking about some sort of a metal forming example, but for example, if you went into some sort of a electronic control unit, you might have in a company a history of all the FMEAs and failure modes, which a new engineer who picks it up, you want to reuse that information without missing anything.
Right.
I did hear about DFMEA here. I did hear about failure modes, but I'm looking at pre-populating an FMEA based on a slightly changed design. Would that be within the purview of what you're doing here?
Well, I'm sorry, I don't know that I've followed all of that question. So you're saying, what's the document, a DS?
Excuse me? No, if you have a DFMEA, right? And if I want to take a electronic control unit or whatever, not just a metal forming thing, but something, and I want to don't want to miss failure. Now, one of the biggest problems in companies is repeat failure modes occurring. The same problem sort of resurfacing because somebody changed the job, somebody came in and he was new and did not take care of all the history of the knowledge of failure modes from a particular subsystem. And if that could be prompted, then it has a direct value to actually reducing warranties and recalls.
Oh, okay. Okay, I follow you a little bit more now. So would it be the case, is the scenario that you have in mind the slightly different version? So I've updated my version of the product. It's the same product, but a new version, a new model, right? So it's the 101A. Nevertheless,
yeah, and
all
say maybe
all
the
the
architecture is slightly. maybe the architecture is slightly different, but I want to make sure that I didn't miss any failure modes before, so that I can go from the previous step and not start from scratch.
Okay, sure, I follow you. Well, it's not an easy problem, but if we're right, then and I'll go back to this little character of a. So here we've got a force gauge that's linked to this particular model. Now, in our case, in Common Core, we have a link that the model sort of prescribes, dictates, guides the functioning, specifies perhaps the functioning of the individual force gauges. And then these things have functions. Now, there could also be associated here a bunch of failure modes. So now I move over and I've got a FB50A. So as long as I can form a link, it seems to me, between that model and the new model, the FB50A, it seems to me as long as there's a link here that I can follow, then I can always get back to my other failure modes. At least that's my initial response to what you're saying. So you wouldn't lose it, provided that you're careful in the construction and the linking between your various models.
Okay. So that model, because the evolution of the derivative of that model should actually keep track of all these linkages. So if I go from this FB50 to FB60,
right,
then I should be able to carry whatever was there before FB60 going forward, such that at least I can devise a way of prompting the engineers that, hey, did you look at this? This was the problem. Did you think of this? Some sort of a search algorithm could be built.
Yeah, I think I understand, and that's a very. I see how powerful that could be. It would be challenging, I think, once you got into, so, the FB50, of course, is composed of many separate subcomponents, subassemblies, and those all have failure modes, but now maybe the FB60 got rid of one of those parts. So do you want to carry those failure modes forward? Well, no, because it's an entirely new part. So knowing what to carry forward and what to leave behind would be an interesting challenge, I think. Like you're using a new airbag, and so all of these horrible things that happen with the faulty ones shouldn't be a problem anymore. Now, I don't know. I mean, do you want to forget about them entirely? No, but
see, that's where my interest in ontology lives. You see, we're going from data to information to knowledge. But half the time, I'm seeing that we are stuck between information and knowledge. So it becomes, again, right. So we don't really boil it up to the level of knowledge, just that it can be used more easily. This is what I am finding. So my question was to you to see how far along you have dug into this, but what you just mentioned here seems to be at least a direction that could be investigated.
Oh, good. Okay, I think that's fair, right? Those are. That's not an easy problem that you mentioned in developing. Data is fairly easy, but I think what we're pretty good at here, and what have been developed with these ontologies, are a good structure for building that. That's our aim. That's our goal in allowing people to develop those insights, to develop information and knowledge based on the data. And it's getting the data structures right, having the available links.
Yep.
And there's even challenges there too that we can get, we can talk about as well. I mentioned one of them, which was you want to keep all the data, but it's a burden, right, on your systems and on your maintenance and so forth. So, but thank you for that question. It's a very motivating one, I think. It's kind of what we're doing this for, is to develop that kind of knowledge from the data.
Thank you.
Sure. Well, okay, thank you for having us here. I'd like to again thank Remo here for the hard work he's done in developing these applications. And hopefully, you've seen enough to at least have an interest in keeping track on how this progresses. So, CERM, I don't know if you have my email. I think you do. But
yes.
I am very happy to field questions, or if somebody just wants to send me an email saying, please send me updates on the progress. I'd be very happy to have that kind of feedback, because this is only going to work if people with a lot of experience take a hard look at it and see how it can be improved.
Okay, so I have taken some notes based on your talk. I'll send it to you for verification, and when then I'll send it out to everyone and include your email in the distribution.
Thanks, sir.